I was waiting just a few minutes to make sure the other members weren't going to come in. Chapter 10 is data and concurrency, our first PLSQL. It starts off with the data manipulation languages, the keywords, insert, select, update, delete, and then the transaction control commands, commit and roll back. In SQL Server, they just call it TSQL for transaction control. So SQL, do you know when I teach Visual Basic, it's object oriented, and then when you look at JavaScript, it's object based. You know, it's based on JavaScript is not considered an object-oriented language because you can't create your own classes like you do with like you do with object-oriented languages. And then SQL is called a set-oriented language, and that's an old term, really, not the oriented part, but it used to be a row set. Everything that was returned from a query was called a row set. You know, just to mean that it was all of the data that was sent back from a query. It is not designed to create user interfaces. So PLSQL is a third generation language used to create procedures, functions, and packages that allow all the things that you do in programming. The SQL keywords themselves are embedded into that PLSQL. When I had Oracle a few years ago, it was all the PLSQL was command line based. Now there's a graphical software called PLSQL Developer, and if you guys don't care, I wanted just to look that up pretty quick. That little thing on my that little thing right there for my camera gets in the way of me getting a new tab. I'm trying not to get too far behind it, keeping up with the classes. Let's see. It's free. Let's look at Oracle's official site on the PLSQL. It's an integrated environment for the management of Oracle databases, both in the cloud and traditional. A worksheet for running queries and scripts. A console for managing the database. It's not in there, is it? Have you looked at you know it's not.
It's not in there. They got a connection for it, but it's not in there. You have to download separately.
Yeah, I was thinking that maybe it did. Maybe it was already in our Oracle. So you see that all the user interfaces, though, that I have ever seen created with PLSQL was a menu-based user interface where the user had a choice to select. I've never actually used that graphical PLSQL. You remember covering case select statements with your C++ programming class. Well, the case selects have become a menu creator, and I'm going to look for code to see if I can find examples out on the internet with the user interfaces. So a transaction is one or more of the statements grouped together, and that's the keyword Go does that. You can select it and run it one at a time, but the transaction is what it's called. The integrity, all parts of the transaction must be complete, or none must complete, or none will complete. I just think back at that SQL in our VisualWorks and the other class that it all runs. When you execute it, the whole thing runs. Usually all DML in one transaction is related to, so that all has to be, all is needed or it wouldn't have been written, I guess is what I was trying to say. The undo segments are used. The example in the book, if a person's salary is tied to a grade level, then they both must be updated together. And then consistency, the results of the query must be consistent with the state of the database at the time the query started. And part of that just leads me back to how long it takes to go through however many rows it is. The example in the text, if the query averages the value in one column, changes to those values should not be made until the query executes for the entire column. And that is the error that Oracle will generate, 1555, if it tries to do that, so that it doesn't run its full course and do the entire update. Isolation, incomplete, uncommitted transactions must be invisible to the rest of the world, so that others cannot see the changes until all the data has been processed. I would really, in my mind, love to see multiple users working with that many records and how they do time management on that, if they coordinate those time management kind of skills. Once a transaction is complete, it must be impossible for the database to lose it, impossible for Oracle to lose the data. A user can issue the wrong DML or may drop objects, but that is a user error and not Oracle. One of the things I think I had put in the course, let me see. We had a discussion going. My personal opinion was that Oracle would be a hard database to hack. And that last thing just got me to looking. A researcher showed that Oracle's database could be hacked with brute force attacks using only the database name and the user's name. So I thought the way Oracle did all of the log files, you know, how it writes all of those itself. So one of the things that I did in the network security class, they're going to investigate 5 different breaches and try to determine the database. It's just got me thinking out loud about what's the databases that are being hacked. And I think you guys said, well, it was MySQL, right? Your mind just... So when I ran across that, I just thought, I've got to put that in the class. So this durable, that's what it says to me. It's impossible for the database to use it, impossible for Oracle to lose data, and usually if it's an error, it's the user and not Oracle. But the security, I've got to do some more research on. With release 9 and 10, merge SQL statement combined, insert, update, and delete with one transaction. So our 11G has that merge. Oracle does read blocks from data files, and we've done that from the beginning. The database writer writes blocks from the database buffer to the data files. And that I didn't open, or I thought I did, open the PDF for this chapter so that you could see that picture if you wanted to see that. Let's see, I thought I had opened it. Executing the update command with the merge statement. Now let me make sure. There's the example. No, it's not the same pages, so that is it. This PDF is a little different from the book. I use it a lot, but I do use the book to do just the summaries of it. It is 381, so that was it, showing you how that buffer was set up. Undo is not, that should be not the opposite of redo. Redo protects all the blocks. A change to a block of a table, an index segment or undo segment. Blocks are placed on any rows and associated with index keys that are affected by the transaction. Redo is generated. The summer process writes the change to the log applied to both the table block and the undo changes. The row ID is the new value written to the buffer. Every row has its own ID. So if a field in that row is updated, then the new value is written back. If part of an index, then if it's part of an index, then that change is made too. Update is carried out by the database buffer cache. All queries will be redirected to the undo data. Only the session during the update will see the new data. Now, what I did was I said there's just too many to put. I guess I got, there's commit, rollback, and save point is on 383. Looking at the statements, there's examples of select, and I need to go back and add those, and we've done select. Then there's executing the insert and the deletes, the transaction recall of commit, rollback, and save point, executing a rollback, and then executing a commit. So those types of statements are not just done by the regular user, whoever the database, the admin is for that table or the owner of that table. The inserts and deletes are managed by Oracle like updates. When they're executed, the first step is to locate the blocks in the cache and copy them if they're not there. With insert, the only information Oracle needs is a row ID, because it's going to put it in there where the other rows are, right? Then for a delete, the whole row is written to the undo block. So if the deletion is rollback, all the data could be reinserted. When we do the lab, it would be interesting to find that log and see what it actually looks like. So for insert, it just needs the row ID. For the delete, it needs all of the rows. So deletes would be resource eating up, and then transaction control. Commit it, roll it back, or save it to a certain point. Save point is not actually a part of SQL. It's a way for programmers to back out of statements in reverse order. It doesn't terminate the transaction. While we were doing this chapter, I wish we were doing SQL in 287, and we're almost there. But you'll remember when we get to that part where you'll see what it's like in SQL Server. Rollback is automatic and completed in the background processes. So, how often would you actually do rollbacks? For human error or something? You know what I'm saying? wouldn't somebody that is doing inserts and deletes and all those be very careful, commit them when they know they're right? But things do happen. We all know they do happen. But I just think rollbacks doesn't happen very often. And as a general rule, it'd be something that you would try to avoid. You know, you want to make sure the data's right to begin with. Some examples in the book, though. A user's computer reboots or the network goes down. So Oracle detects a problem and rolls back. And we've had that happen, right? I've had it happen when, just the network, when I didn't have enough time in NetLab in my scheduler, you know, and it's stopped. So if the server is rebooted while the database is open, Oracle will detect the problem and initiate a rollback of all active transactions. So what this is saying is that Oracle doesn't leave those things up to the user. You know, the user can do rollback statements, but Oracle doesn't leave the kind of hardware things that can happen, doesn't leave the rollback up to the user in that case. So for the commit, the log writer flushes the log buffer to disk. The database writer doesn't do anything. One of the most important performance points, and that's under the commit. That's 385, and it talks about the whole process of the commit, how the commit actually works. And there again, it would be done as a matter of company policy. But it says in the normal running, the database writer only writes a few dirty buffers to disk. When a checkpoint signal, it writes all the dirty buffers to disk. So part of the commit is looking to see if everything is okay, you know, before it actually does that commit. The rollback and commit statements themselves are only applied to DML, inserts, updates, and deletes. The DDL is not rollbacked. If you create a table that creates a data dictionary, so the create command includes the commit. So there's a little bit of difference in how that works and what it, you know, whether it's there or not. So remember, and my mind, I want it to fit logically. I want selects to be DDL. I don't want it to be the data manipulator, but it's not. So that pertains to selects, inserts, updates, and deletes. But selects are just a query that doesn't change the data. Do you see? So they wouldn't be rolled back anyway. Do you see what I mean? The insert is add new data, update is change data, delete is delete data. So those are the three really that would be committed or rolled back. The selects themselves, as we know them now, are not committed. Implicit commit or auto commit, the create commits includes the commit. There is a commit written into SQL Plus without an exit command. If the window is closed with the X on the window itself, there is a rollback included. Now that's kind of some key points. If you were doing it every day, that would be some key points that you'd really want to make sure that you paid attention to. That I've seen other applications where closing the window with the X itself was different than closing it with the buttons on the window. So 10.1, and let me see. I wanted to show you that. I thought I would start opening them up. 10.1 is running those statements. You create a table. You then delete it. You select all the rows. You roll it back. You select them again. You delete them. You select. You do the rows again on the same one. Create a view. Select all the rows. Roll it back. Select all the rows, and then drop them both. Now, what I've done a lot when I was doing these labs, sometimes I didn't drop anything. I didn't delete the tables once I created them. It does that to show you how, right? But sometimes I didn't. So the DLL statement committed the delete, so it can't be rolled back, so they dropped it. That's a little bit confusing to me. I've got to see it in action. I've got to see that one run. Is it deleting the entire? When it's doing that, delete from T1, is it telling it? There's no data in that table. I've got to run it. So I'm getting a little confused myself because of this statement right here, that it can't be rolled back because it was a DLL statement. Okay. So just lab 1 is DML, running creates and deletes rollbacks. Then 2, the second section, what I did was I put us a link here. Out to the documentation. I found a PLSQL language reference on that link. Has the examples, has a list of tables. It gives us a really good look at what PLSQL is. So the language syntax, the data types, the control statements, collections and records, static SQL, dynamic SQL, triggers and packages. Packages are a group, that they're all going to be working together to do something. So that link is a pretty good link, overview at PLSQL. And when you look at job sites, I need to do that too. If you look at job sites and it includes PLSQL, it's going to be a higher job. It really is. It's a lot of users just run selects to run the queries to pull out the data, but PLSQL is real programming that could affect, and change a lot of the data by mistake. Since it works on a trigger kind of basis, it's just a deeper set of code than we're used to doing with SQL. So, and it is just for Oracle. It did not used to be just for Oracle. That may not be a good statement because my SQL might have called that something different besides PLSQL. It extends SQL to include procedures and functions and generating user interface code. And like I said, the only interface I've ever seen is a menu. It allows programmers to manipulate rows one at a time, third generation language that runs within the database, conditional statements, loops, all of those kind of things. It is compiled. SQL is not compiled. The code is stored remotely or created within SQL Plus. It's called anonymous, and there's a code sample on 391. Let me just go back real quick to Blackboard. No, I haven't. So on 391, you might not can see that really good on the screen. There's an example that creates or replaces a function called odd and even, return the data type, as begin if the mod, the variable name, 2 positions equals 0, 2 decimal places is what that means, then return even, else return odd and if. So what it's doing is just looking at numbers to tell you if it's odd or even or not. So the function was created from the dual select and then run it. Let's see. The name, it's the first example on 393 is a function. It's going to return one value. On the bottom of that page is a procedure called ins-ints. And do you see that can return more than one? So the procedure was completed, and then they use a select statement to display the output. This is the PDF that I had. It's actually a little different than the book. Different. Let me think now. They're both 11G. Those PDF files and the book are 11G, but I'll need to check, see if one of them is the revision or not. So code can be anonymous or stored, which is more efficient. The objects, the procedure. Let's see, I didn't. Can return more than one value. In our case, that can be the rows themselves. The function, generally speaking, returns one value. Now, the package, let's see. And I did. I didn't get it finished before I uploaded. I can see that now. The package is a group of related. They're in programming. It's the same concept, like with Java or any other language. If you're going to create a large project with multiple programs, and sometimes those programs are written in different languages, then you give it a package. Do you remember C++? The only programs we run in that class is using namespace standard, right? So the package is a container that holds a project. Now, how can I say that? More than one procedure. You know, they're related. For example, more than one related procedures. That's what a package is. The body, To create the package body, you use create or replace package body. It's code. So a package consists of two objects, the specification and the body. So in programming in general, that works. It's a little bit different with PLSQL. But it lists the functions and procedures in the packet with their call specifications. I know for the two people sitting here, I don't need to review that, right? But just in general, there's a function definition, right? That's what this is talking about. Is the package body, and then there's a function call. That function call is the trigger. So now let me. So you create the package in SQL, PLSQL. You create the package. In that particular example, it's creating or repacking or replacing package named numbers as the function odd and even, return the variable, the procedure, return the integers in numbers, the package was created. Then to create the package body, you use that syntax to create the individual ones. There's several hundred PLSQL packages provided as a standard in the Oracle database. So we've got common things that you might want to do like this that are already created, and then you create your own. Okay, then the trigger is the call. The first line, and I'm going to go back and add to this handout. The first line on 395 says that they're a special category and they cannot be invoked manually. The trigger runs or fires automatically when a particular action is carried out. So that's where the event driven programming comes in, like we're used to in VB. There's a number of possible triggers. The event, the insert, delete, update can be an event. Whether it's done before or after, you have to decide as the programmer. Then the DDL triggers are create, alter, drop, and truncate. Database operations, server error, log on, log off, start up, shut down. Then there's a suspended one. Those are on 395. When you're writing your own, then you can use these commands to do it. I've seen triggers that had their own names. Then on 396, there's no trigger on the select, although in chapter 12 it says that you can alter that to produce something similar. Numerous uses, auditing users' actions, executing complex edits, security, enforcing constraints. I want to look at, have you got Enterprise Manager up, either one of you, in NetLab? I wanted to see, well, we don't have to do it there. We could do it right here. I just use Google rather than Oracle. Oracle is so explicit with its names. I wanted to see if we could just get introduction to Oracle supplied PLSQL packages and types. So in their documentation, you can get a list that gives you those predetermined ones. The separating the specification and the body. So there's the create package. The name of it as a function. The hire date is the name of the function. The procedure to fire employee, the procedure to raise their salary. All of that is called employee management in that package. But that's still, here it is, finally, here it is. Summary of Oracle supplied PLSQL packages. So there's an alphabetical listing, and it's management, a lot of it, management of different things. If it's already been created, why would you wouldn't want to recreate the wheel, is the basic reason for them. Goes down to XML at the end, looking at some of the types. So I'll put that link if you want to look at it again, look at it some more so that you can get a feel for what those supplied PLSQL packages are. Then lab 2 is entering in as the system user, creating a table. Then you create a package. And you're actually using the Enterprise Manager to do that, not the command line. All of the code samples that we've had has been using the PLSQL editor. This one's using the Enterprise Manager to do that. It creates numbers as a package name. It's in the schema or the user of the system, and that's the example that they were showing us in Lab 1 to return if they're odd or even numbers or not. One of the things I'm a pack rat, but one of the things I really regret is when I went, when we did Oracle, it was 9, version 9, and I had a sloosh of Oracle text for 9. And when I was cleaning out, Sneed didn't teach it, and I thought I'll never need those again. And that's one thing I wish I had those texts back, because those texts had a lot of examples on how to create your own PLSQL functions and procedures. It just took it to a more level than this did. I can't get them back, but I kept them for several years, thinking I would use them. And I thought, Steve don't teach it, I don't need it. So you get so many books. So many different subjects. I did away with, I still have my RPG because that's the first language I ever taught. I threw away Ada, all of those books. The next section is monitor, resolve, lock and conflicts. Can we just stop, because that's all it is Lab 1 and 2 for PLSQL. The conflicts is the third one, and that this is the commit and the rollback and all of those, and how you would lock it to do that. So that's what's in the third section. So these first two sections, all it is, that's all the PLSQL we get. So we have, though, about 30 minutes left in the class. Would give us time to enter NetLab and work on those two. I'm going to work on making sure I have good definitions for the things that where I just stopped. I'll try to use the terminology that the book used too. I'm going to stop my video just for a minute. I'm sorry I've kept it running. Just pause it. Here they are, the packages, the package bodies, the procedures, functions, triggers, Java classes that have already created that you can just generate objects from those classes. I looked at a trigger, and you have to have the object to run that trigger against. There again, you got to have the object. Let's see. Okay. I want to look at some of them's name. And you can't. I don't know what the objects' names are. So it's included in the Enterprise Manager for this chapter 10. Lab 10.1 executed flawlessly. 10.2, when we got to the very last step, we got an error. So that's where we stopped for today. Have a good weekend. I'll see most of you tomorrow morning in in SQL Server.